Hey everyone, Steve here from ProgrammingMadeEasy.com, and today I just kind of wanted to give you guys a video from my other channel. Some of you guys may or may not know this, but I have another channel called Coffee with Steve. It's at coffeewithsteve.info, and you can go check it out. I do these kind of live commentaries on things. I pick some sort of topic for the day and just kind of chat about it. I hope to see you guys over there. Once again, it's coffeewithsteve.info. Now, this particular video was on test-driven development, and I figured this would be a good opportunity to show you guys what kind of content I've been putting over on that other channel. It is also obviously relevant to this channel too because it's about programming. So I hope you guys enjoy. Hey everybody, I hope you guys are doing fantastic in lockdown. Boy, it's been a while since we've been able to really get out, huh? So, hey, thank you so much for joining me today. I know these live streams have been a little bit few and far between. Obviously, there's just things going on in my life that are hard to get away from that. I really would love to be able to do this on a daily basis, but man, it's just tough sometimes, especially coming up with content for you guys on a daily basis and working full time and all that. So I'm thinking about kind of cutting down on that promise because I can't achieve it. So maybe do like one of these once a week. I'm just kind of thinking, just kind of tossing that out there. Maybe once a week would be a good way to do it instead of trying to do once a day, because I've been failing miserably at that goal. But anyway, so let me know what you think in the comments. Let me know what you think, in the live chat. If you think I should maybe cut it back to once a week instead of disappointing you guys every day. Okay, just want to make sure I got my chat window open so if you guys are chatting with me, I can see it. So today, I wanted to talk about a topic, test-driven development. You may or may not have heard of this term. If you're an Access developer, you probably have a difficult time even knowing what testing is all about. We don't really do tests in Access. But, in like C# and Java and Python and all these other languages, JavaScript, we do testing, right? We do unit testing, we do integration testing, we do all sorts of different testing, right? I hear a knock on my door, I think. Is that you, babe? I don't know. Well, I heard a little tick, tick, tick. I don't know. Could be anything. Anyway, so testing. Testing is all about basically creating automated tests. This is code that you write that makes sure that your application behaves the way it's supposed to, right? And we kind of break this down into typically 3 different categories of tests. We call them unit tests, integration tests, and end-to-end tests. And the unit tests are for just kind of the smallest pieces of your application. So if I have a class with a method on it, I'm going to write several tests to make sure that the inputs and the outputs of that method are correctly designed and give the response that they should. And there's a philosophy out there called extreme programming that is really kind of the first agile set of principles and practices, right? It's kind of the first set of values stated, written by a gentleman by the name of Kent Beck. And I've been following Kent Beck's career for quite a while. I mean, he's really kind of one of those guys up there with Martin Fowler, Uncle Bob Martin, you name it. If it's a pretty big name out there, Kent Beck is one of them. And he came up with several different practices of the extreme programming philosophy, one of which is test-driven development. Another really good one is something called paired programming. You may have heard of paired programming, where you and fellow developer work together on a piece of code. But there's several practices that he suggests that you do, and one of them is test-driven development. Now, the idea behind test-driven development is that you start off with a test first that is already broken. So you haven't written a single line of production-ready code. You've only written a test, and the test is designed to fail. It's supposed to fail. So you write a test. It's a very small test. It's only supposed to show that one little tiny piece of the application doesn't exist yet. And so you write the test, and then you go and create some bit of code to make the test pass, right? So you write your tests first. That's why it's called test-driven development. You're driving the design by testing first. So you test, then you write the implementation code that satisfies the test, and then the third thing that you do with this is that you refactor that code. Okay, so you design a test, then you write the code that, the implementation that satisfies the test, and then you go back and you refactor. And the idea is when you make this test green, we call it the green phase, you're writing the simplest possible solution, right? So when you're in green phase and you're just trying to make the test pass, you're just trying to make the simplest possible solution. It might be the dumbest. It might seem like this has absolutely no usefulness to it whatsoever, but that's not the point. The point is to have a test in place that makes sure that all future revisions of your code will still work and that particular use case still works. So even if the implementation is dumb, the test at least indicates that the code that you wrote will work for that particular use case. So you just basically write these unit tests first. You write a test first, then you write the code to and just one test, by the way. You don't write a bunch of tests. You just write one test. Then you go to green phase, which is you implement something. It could be as dumb or as stupid, as simple as possible. And then you go through a third phase, which is, how can I refactor this? These are things like, should I rename this thing? Is there a better way that I might be able to make this work? And that's where you kind of start making that evaluation of things. So that's kind of the test-driven development cycle. There's something else that I want to tell you about. So, by the way, that was unit tests. Okay, that's just very small little pieces. Integration tests are a way of saying, I have this component here and this component here, and I want to make sure they're both working together correctly. Right? I give this component the information it needs, and then I send it over to this component. And because you are actually testing two things or more at once, you're kind of testing to make sure that the integration and how those two things are interacting together is actually working properly. So you've got unit tests, which are individual, just checking the little tiny pieces in and of themselves. Integration tests that is just kind of checking two or more parts of the system at the same time. And then end-to-end tests are really kind of what it sounds like. Like if I was the user, I would click on this button, I would expect this result, right? It's very kind of user interface driven. It could also be theoretically the API that is being interacted with, say like for a RESTful service, where you're just making sure that if I receive this JSON from a post, for example, that it goes all the way back to the database and comes back with the data that it should, or maybe you circumvent that, or you're spying on it or something like that. But the idea is whatever you say the user should see at the end of your application, whatever that entry point is into your application, that they are able to interact in a particular way and receive the results the way that it's supposed to. And that's called an end-to-end test. So really an end-to-end test is just an integration test, but it goes all the way up, right? Anyway, so those are basically the three different types of tests. Test-driven development, you can do test-driven development using end-to-end tests or using integration tests. You can actually start with one of those higher level tests first instead of unit tests. And there's kind of two different design philosophies around this. There's the Chicago versus London style, they call it. I prefer, honestly, the terms inside out or outside in. It just kind of makes a little bit more sense to me than just Chicago versus London, because who knows the context. But outside in testing is essentially when you're doing test-driven development, right? You're writing your tests first. The first test you write is an end-to-end test, the highest level possible. When I click on this button, I should receive this result. Okay, and then you design the system that's just the simplest possible design system to get that test to pass. And you can implement a bunch of code, right? You're not doing unit tests. You're doing a bunch of code from all sorts of different, building different classes to finally achieve whatever that outcome should be. And so that's the outside in philosophy. Inside out is where you start with the unit tests first, and you just kind of keep building on top of that. So you don't really necessarily know exactly how the design's going to how it's going to come out. Outside in, typically you kind of have some idea how you're going to design the system to begin with, right? Survivalizer. Okay. Today, I wanted to talk about this talk that was given out there. I came across this video. I was watching some Kent Beck lectures on YouTube. Some really good stuff. He just recently, back in 2018, he was let go by Facebook. He was working for Facebook for like 7 years. He was let go by Facebook because he was discovering some things that just philosophically, based upon improvement metrics of developers, for example. He was finding that these developers were being held to a standard that was just simply not achievable because they were in a different business. What's a different strategy that they should take on, right? So he believed that there should be a different strategy than what they were currently doing. So anyway, it caused some problems for him. He ended up leaving, and I don't know if they let go of him or he let go of them or whatever. But he came out of this thing called the 3 E's, and I'm not going to get into that. You guys can watch it some other time. But as I was watching this series, one of the videos that came up that was suggested was this video, and I'm going to switch over to it here. No. Okay, yeah, that's it. So this was in 2017 by a gentleman by the name of Ian Cooper. And I want to first and foremost say it's always good to have dialogue around these ideas, right? You have to have some sort of... You need a blunt edge in order to sharpen a sword, right? You got to have something that you're kind of rubbing it against to see, get some sort of conflict there, right? In order to make sure that your idea is solid, to really kind of analyze your position. Am I right? Am I really right when I say this? So when somebody comes along and articulates a different perspective, especially one that comes from experience, it's really important that you listen to them and hear what they have to say and see if that changes your opinion at all. And you need to make sure that you're not being dogmatic about it, but just see, are they properly assessing what that is? Are they explaining problems that truly exist with the design or the idea that you are working with? And you need that. You need somebody to come and tell you, hey, and challenge you on those principles. Otherwise, how will you ever know that you're right? You need to be able to kind of combat that. So, I want to first and foremost, Ian, I don't know if you're ever going to see this, but I want to say thank you so much for doing this presentation. Unfortunately, I was not able to finish it because I found so many things wrong almost immediately with it that I really thought it might be beneficial to just kind of go over this. And because there's a lot of misconceptions about some of these philosophies like test-driven development and agile and extreme programming and solid principles and things like this, that it starts to kind of become a jumbled mess, and you get a lot of different ideas that come out of it, and people start blaming the wrong things for problems when they arise. So the first thing I wanted to do, and I want to make sure my desktop media source here is, desktop audio is up. Okay. So we're going to start off here. I got him at 7:10, and let's just listen to what he has to say here.
This is... You quite often got the situation where, some project manager would turn around and say, guys, look, couldn't we just skip the tests? We've done so much faster. We get out to market a lot faster. I know you guys like doing good engineering, etc., and I really get that. But it's taking us an awfully long time to write all these tests. Couldn't we just ship the code? It wouldn't really matter if there were a few defects, in production, right? Couldn't we just not do the test? And we'd say, no. You don't understand. The way we write code is by writing tests. We can no more stop writing the tests than we can write. This is our, the standard mantra, effectively. Tests are part of our practice for writing code. You're just telling us to stop writing code if you do that. And they'd go away going, okay, fair enough. We get it. You guys want to write tests.
So he's already kind of setting this up that a very common issue that you hear about tests, and this is the funny thing. His whole talk is about against TDD, well, I shouldn't say against it, but he's more or less like articulating what the problems are with TDD, and where it all went wrong, right? That's how this is headlined. Some sort of rep coming to you, some sort of stakeholder with the application coming to you and say, hey, can't we just skip the tests? Can't we just put something in production? My argument to this is like, why can't a doctor just go in and operate? Why do we need the safety features? I mean, it's just slowing them down. You might save life-saving precious seconds if you can just get that doctor to jump in there. Right? And yeah, sometimes doctors will kind of ignore safety protocols and then get hammered later for doing it. Rightfully so, right? Because we need these type of protections to make sure that things that could go wrong don't go wrong. And that's what tests do. They provide a way for us to make sure that we are doing the best practice. We should be living up to a standard of professionalism. Okay, and that's what this TDD and agile and craftsmanship is all about, is making sure that you are writing good quality code that is professional. Okay, do you take yourself seriously as a developer? If you take yourself seriously as a developer, would you ever want to let code go out into the wild that doesn't have testing? That doesn't fully test everything about it to ensure that it works? I wouldn't want a doctor that I don't have that same type of protocol around. Why should we as software developers have anything different? In fact, I'd say we are probably even more important to the infrastructure of the world right now as programmers than even doctors. I know that's a bold statement, but if you start thinking, what do the doctors rely upon in order to do their work? They rely upon all sorts of different machines and programming, right? Like there's a ridiculous amount of code out there that we as developers have written that is life-saving. And if we get it wrong, the doctor is helpless to do anything about that, right? And we have such a huge impact that if we just say, no, it's okay. Our profession doesn't really require that we test everything. That seems like a pretty large breach of confidence with society. Okay, so anyway, we're going to move on here. So he continues on.
But we were slower. I mean, that's just a reality. We were, 20 to 50% slower than we had been before by writing tests.
Okay, so this goes together with what he was saying before. Like, they want it just to be done fast, and he's saying, yeah, we were slower doing test-driven development. Okay. I would also say, compared to what? Because if you start thinking about how you design a system, when an application gets, to a year or 2 years old, you're quite often just fixing bugs. You're not releasing anything new. You're just fixing stuff that's already out there in the wild, especially if you don't have tests, right? If you don't have any tests that are out there to make sure that the system is still working after you make a change, then you end up having to spend a ton of time. If you want to introduce a new feature, you have to do a ridiculous amount of fixing in order to make that feature work properly. So that is a lot slower if you don't have the tests. So in 2 years, and yes, I'm projecting out to 2 years, how long would it take you to release a new feature? If you've been doing test-driven development and have unit tests and integration tests and end tests that ensure that the system works properly, you're going to be releasing features at a much faster pace because you don't have to fix everything every time that you make a new feature release. That's the way it is. So when you say it goes faster, you just need to make sure that the person coming to you that says, hey, can't we just, do this a little faster? As compared to what? As compared to what? Something that's going to break in 6 months? Is that really the trade-off that we want? That's what you have to be saying. So the argument, I understand what he's saying. This is what other people who don't understand programming are coming to us and saying. And again, that's like saying, hey, doc, can't you just do the operation? Can't you just go in there and take your scalpel extract that spleen? Why can't you just, get in there? You don't need the scrubs. You don't need the gloves. You don't need the sterilization of all the tools and instruments. You don't need to do all that. You can just go in there and just take out the spleen. I mean, it'd be faster. Okay. Sure. Yeah, that would be faster. What kind of argument is that? Why would you do that? Okay. All right. That's what we need to be saying. Not this, oh, well, we kind of understand their plight. No. We're the professionals. We are the ones that are going to be held accountable for the work that we do. You are not. Right? That person is not going to be held accountable for the work that we do. It's going to come down to us. And then when things break, they're going to say, why did you let it break? And, well, Todd came to me and said it needed to be done today. Whatever. Okay. Let me check real quick before I move on. Oh, hey. I have 5 people watching. What do you know? Okay, so let's keep criticizing this Ian guy. Honestly, again, I'm glad that he's doing this, and all the kudos to him for even getting the guts to do this in front of a big stage of people and putting it on YouTube and stuff. Anyway, let's keep going.
The other thing I noticed over time was with some of these big test suites is that when we wanted to change something, we quite often break a lot of the tests. And quite often what we were doing was simply refactoring. We were going, oh, well, we've added some new features to the code, and now the shape of the implementation is a bit wrong given these new features. And I can think of a better way of organizing our code, make it more maintainable. So I'm going to refactor the way the code is organized. I don't want to change the behavior of the system. I just want to refactor the shape of the code so that essentially it's more efficient. And a whole lot of tests would break. And a lot of the time the tests that broke were the ones that were heavily mocked. Because these mocks were telling us exactly what ought to be happening in the calendar test. They were saying, oh, first you should be calling this twice, then call this, and then call this and put these parameters on it. When we refactor something, we quite often changed how that worked, and all these tests with mocks, they broke, and we had to rewrite all the mocks. This was kind of puzzling, right? Because the promise...
All right, before I get into that, so what he's essentially saying here is the tests didn't break. I think that's the wrong term, and maybe if he went back and thought about it, he would reuse a different phrase than this. But the tests didn't break; they failed, and on purpose, right? That's what tests are for. Is if you change the implementation in such a way that the tests are currently passing, but you change it so that they fail, they're gonna fail, right? Like, that doesn't mean the test is broken. That means you change the implementation to something that was a solid state, a good state, right? The application was in a good state. That's what the tests proved. You went in and refactored and changed it. The tests are going to break. That's how it's supposed to go. That's exactly the purpose of the tests, is to make sure that you don't go just fiddling around and messing with things when the design implementation that has been relied upon for a long period of time of how that thing is supposed to work, it's been relied upon. You have a lot of code everywhere that is saying this is how that class or that method is supposed to behave. If you go in and change that behavior, it's going to break the test, but not only is it going to break the test, it's going to break all the code that is referring to that code, to that piece that you just changed. And that's the whole point, right? That's why we do the testing, is to say, hey, wait a minute, the test broke, but that's an indication that other pieces of the application might be broken as well, okay? That's what the test represents, is all those other calls that you might be making to that same function. So here's the main problem. And this is really a problem of his own making, okay? Because solid principles, there's one of the solid principles called open-closed principle, which basically says you should write your code open for extension, but closed for modification. You should not be changing the implementation. You should be extending it to add new features to it or add new functionality to it. But you're not actually adding it to that one. You don't have to add it to that specific system. You can create a whole new system that uses the old system. And then you have a new implementation detail that you can start to write that code around, right? So the bottom line is you don't modify existing code. That's not what you do. You don't modify existing code. You don't go into a class or a function and just start tinkering around with it to change its implementation details. No, you create a new method or a new class with a new method. And that may use the old one to do some of the logic. But the bottom line is you don't change the current implementation because you don't know what you're going to break if you change it. Okay? So you make something new. Now, if you make something new, now you have something new you can implement wherever those changes need to be. So if you have something that you have a changing requirement from the client, you write new code to implement that requirement. And so you write new code. You don't change the existing one. You write new code. And then you implement the new feature with that new code. And you write tests, new tests around that code. That's how it's supposed to work. That's the open-close principle. So this is not a failing of TDD. In fact, this is a prime example of why you do TDD. You should not be changing your existing code. Your tests are breaking for a reason. Don't modify your code. Make new code. That's the whole point. Now, if you get to a point where, okay, that old implementation is no longer in use, guess what you get to do? You get to delete it. You get to clean it out. You get to remove the old brittle code that is no longer implementable and all the tests that go along with it. All those tests are going to fail, right? Because you just remove that implementation code. You get to remove those tests as well. Okay? So anything that if you have a completely new implementation, a new design request, then it should be new code. It shouldn't be changing the old code. Okay? So that's just a flat out misunderstanding, I think, and this has nothing to do with TDD. This has to do with him not obeying the open-close principle, which is something we're going to see quite regularly through the rest of his talk.
Was that we should be able to refactor our code, keep it basically fit and clean. We wouldn't get into a big ball of mud craziness.
Let me back it up a little bit here, because I think
when we refactor something, we quite often changed how that worked, and all these tests with mocks, they're broken. We had to rewrite all the mocks. This was kind of puzzling, right? Because the promise was that we should be able to refactor our code, keep it basically fit and clean. We wouldn't get into a big ball of mud craziness. We wouldn't really see our code rot before us, because our tests would enable us to refactor, and refactoring kept our code healthy.
That is incorrect. That is not what tests are for. Okay? Tests allow you to ensure that the stability of the system in its current state is working. When you want to go and modify the application, you should be doing it in such a way that you are implementing the solid principles. Single responsibility principle, open-close principle, Liskov substitution principle, interface separation principle, and dependency inversion principle. Okay, those are the principles that you should be doing in order to have the flexibility within your system to write new code that doesn't break, that is not brittle. It's solid principles that does that, not TDD, not unit tests, not testing. Testing is just ensuring that the current state of the application is working. That's all the testing does. Now, when I go and make a change, when I go and add something, I want to make sure that I don't break the already existing code, right? So in that case, in some way, that's what TDD promises. That's what unit testing period promises, is that we are not going to break the current state of things if we add new code. That's what the promise is. Solid principles are what helps us with the flexibility to be able to change things on the fly. So again, this is kind of, he's conflating two completely different ideas together and saying it's the fault of TDD. It's not the fault of TDD. TDD is doing exactly what it's supposed to do. It's telling you when you break the system. That's what it's there for. Okay? All right.
When we wanted to change our code, actually the tests were an obstacle to that change.
That's right. Tests are an obstacle to change. That's their whole purpose. That's the whole reason you test, is to make change difficult so that you don't break the current state of things. All right, I'm getting a little impassioned here. Let's keep moving before I flip my lid.
Because they increased the amount of effort we had to put into making any changes. Because we had to fix all these tests that were breaking when we changed our implementation details.
Fix the tests? What do you mean fix the tests? You shouldn't be fixing tests. You can write new tests, you can write new code. You shouldn't be fixing tests that are already a part of the system state. If you're doing it wrong. It's not the fault of TDD, you're doing it wrong. You need to be doing your tests to make sure that what you have in production is good and working. If you are changing the implementation, right? If you're going in and modifying the code that you wrote tests to and it's breaking the tests, that doesn't mean you go to the tests and you fix them. It means that you are on the wrong path. Don't change the already existing working code that people are already relying upon. Don't change that. Make new stuff. Write new code. Write new tests. That's how it's supposed to go. All right, let me just take a quick gander here. Where are we at on? Okay, we have a question. What you mean you don't just change the stored procedures on the fly and do Control F to find where you broke the calling procs? Yeah, right. Stored procedures, and this is why you never put. I've gotten away from stored procedures. Definitely avoid triggers on databases. Any sort of business logic that occurs inside of your database is a flaw of design. And honestly, architects that say that this is what you should do, I understand the motivation. You want to have, you have a big beefy server that's doing all the SQL and it's closest to the data. And I used to think this too, is stored procs are great. But the bottom line is then the developers who may not even have access to the database, may not have any sort of ability to see into those stored procedures, don't understand what the logic is of the data that's being returned or how it's being calculated or what it's triggering or any of that. So really stored procedures and triggers especially are really, really bad things to do, in my opinion. That should all be in the code. That way the developers who are interested in the business logic should be the ones that are that can actually see what's going on and design how the behavior of the system is supposed to work. Yeah, it really bugs me when I see triggers and stored procedures, not so much, because again, I kind of see them, but they should be moved out of stored procedures and into the code. Okay, let's continue on.
That didn't sound right, because surely what Martin Fowler and Kent Beck were telling us about refactoring was that refactoring was changing the implementation details without breaking tests. Yet our tests were breaking.
That's wrong. That's wrong. And I just told you all why I don't need to recover it, but that's wrong.
All the time. The other thing we began to notice was, I guess it's about 2009, 2010, a whole lot of methodologies began to emerge that explicitly said don't do test-driven development.
I'm going to skip ahead a little bit here because he gets kind of a little verbose. I'm going to jump to right about there.
Go to approach of the California, the Silicon Valley startup was saying, don't do tests, right? Ship working code to customers, get it out there, fast as you can, get feedback, because you may be building the wrong thing altogether. You might want to throw it away. TDD is a kind of practice you do later on when you're scaling, right? But don't do tests, it slows you down too much. So there's this whole pressure saying, TDD is a bad idea, because TDD really slows you down, and you're better off just getting feedback.
Okay. The thing I want to say about this is, once again, this is not an argument against TDD. This is an argument against tests. Right? If, just ship it out, we'll let feedback drive how we're going to make changes to the system. Okay, so again, let's just put away the side that, that's saying, hey, don't be professional. We'll put that thing aside first. But that's really just an argument against testing in general. It slows you down. So don't do it. Okay, so here's what I typically say. First of all, can you and I agree that we should have automated tests that ensure the state of the system is working? Well, first of all, we can even start with that. Do you want working software? Do you want to know that your application is working? If the answer is not yes, I honestly don't want to work for you. I don't want to do your application. I don't want to build your app. If you don't even want the application to be working, or if you as a developer are telling me that that isn't the goal of what we should be doing, I don't know that I can trust you as a developer. I wouldn't want to work with you. The first thing that we should be concerned with is that the application works. Okay, how as we developers, us as developers, how can we ensure that the application works as designed? Well, you can put tests in there. You can write automated tests to ensure that all of the functionality you wrote works and behaves exactly how it's supposed to work. Okay, great. So you and I can agree then, hopefully, at that point, that testing is the best way to ensure that the system works. It is working code. Okay. So really what we're saying then is we need tests. We should have tests. Now I would just ask you, when do you write the tests? And if you say after, I'm going to say, okay, that's fine. You can do that, but I found that it's a little bit better if I do my tests first. If I write my tests first, I'm much more likely to ensure the completeness of the system and the completeness of my testing harness. Because I essentially, every single bit of functionality I write into my application has a test around it. And I know that because before I even designed that thing, I wrote a test to ensure that it happens that way. Okay? Whereas if you go and write your code first and then try to retroactively add tests to it, how sure are you that you did add all the tests that you need to add to it? How sure are you that you've got 100% completion coverage of your application? How sure can you be of that? If I do my test-driven development, there isn't a single line of code that goes in there that I haven't already written a test for. So, I mean, now, if you and I can agree that we need tests, first of all, if you and I can agree that the application should work, right? Okay, the best way for us to do that is through tests, right? Okay, great. So best way for us to do that is through tests. Now the question is, do you do it before or after? And that's where we can have the discussion. That's where we can say where TDD may or may not be a good idea. Okay, that's kind of the realm that it's in. But don't conflate TDD with testing. It's not the same thing. Test-driven development is not, test-driven development is not the argument for testing. It is just an argument that says you are better off as a designer and engineer if you write your tests first. Right? You have a better craftsmanship, most likely, writing your tests first. It's just a way for us to know that. And how do you quantify that? Well, it'd be kind of hard to do that. You'd have to do some sort of like bug analysis between the same exact application written by one developer who did it with TDD and another developer that tried to do tests afterwards. It's kind of hard to exactly prove that. But I mean, if you just think about it logically, do some thought experiments on your own, you kind of come to the conclusion that, yeah, if I write tests first that ensure that every line of code that I write is already pre-tested, I think that I'm going to have a better testing harness around that. I think that just totally makes sense. If it doesn't make sense to you, that's fine. You can add tests after. And you and I can have a discussion about whether or not TDD is going to work. But the bottom line is this guy is arguing the wrong things. He's arguing about tests, not test-driven development. He's arguing that tests are not necessary. That's a completely different discussion, and one that I vehemently opposed. You should have tests in your application, period. All right.
You guys have the expression over here, duct tape programmer? Maybe. So duct tape programmer is this really annoying guy, right? And every organization has one. And he's the guy the business or the product team absolutely love because he just gives them solutions as fast as he can. And as a requirement comes out, and they say, let's give it to Bob. Bob will just get it out the door really fast. And the rest of the team are going, But this is crazy. And you're going, we hate Bob. Bob's engineering is rubbish. We spend all this time maintaining the stuff that Bob's written and having to rewrite it. And it's really annoying because Bob gets all the credit, right, from the product guy. The guy's going, Bob's fantastic. He's so receptive to our ideas. He just pushes stuff out. And the rest of you going, but it's so hard to maintain Bob's code. It's terrible, right? But they love Bob because Bob delivers for them. You're still writing your test suite, and Bob's shipped the code, and it's running. Okay.
Bob shouldn't be employed. He's not a professional. I've run into many Bobs. I bet a Bob worked for Volkswagen. And that's how we ended up with multi-million-dollar lawsuit against Volkswagen. Is because Bob said, yeah, I'll do that. Again, this is not an argument that TDD is wrong. This is just the criticism that people who don't understand programming have against programmers that are professional. And again, I take it back to, hey, doc, I don't know anything about surgery, but I don't understand why you got to scrub up and why you got to sterilize everything. Why can't you just get in there? Why can't you just, run in like I see on TV and just, go in there with a scalpel and extract that spleen? Why can't you just do that? Why do you have to do all the cleaning stuff? Why do you have to sterilize everything? I don't know anything about what you do or why you do it, but I have this weird curiosity, or just something doesn't make sense to me. Why don't you just forego your professionalism? Because I have, I just think that it's not the right thing. Does that make any sense to anybody? And then they find the one doctor that's a quack that, has extracted a few spleens, and sure, a few patients have died from infections, but he's really fast at it. He's really, really efficient at getting those spleens out. Yeah, some people, get serious infections after be re-hospitalized, but, he gets in there and gets it done. They're triaged later, at the hospitals, and some other doctor has to fix whatever it is that he broke and the infection that patient's fighting off. But, that doctor, he really got that spleen out real fast. What kind of argument is that? We're professionals. We are software developers. We are writing code that people's livelihoods depend upon. From anything from healthcare to, I don't care if you're creating a POS system for some business that is, selling goods. If you're writing a point of sale system, people's jobs and livelihood depend upon that system working. And we know this, right? And if you've ever gone into a retail store and they say, sorry, our machine is down, you just lost a customer, right? You just lost a sale. Somebody's not getting the money that they could otherwise have. Somebody might even lose their job over that. We are talking about livelihoods because of software development. I don't think people realize how critical we are to the infrastructure of the world right now. And if you are not taking your job seriously as a developer, then and just giving in to these requirements like this, you really need to have some deep introspective look at your level of professionalism. And I know that's a mandate against several of you. I know a lot of people, I used to be this way, right? I just get it done. I can get that done. I don't think there will be any problem. But as I've grown up and I've matured, I realized, wait a minute, there's a lot of people that depend on this stuff working as it is designed. And if I'm just going to be that duct tape programmer Bob that just gets it done, but then later someone else has to triage it, someone else has to fix it, that's not good. That's bad. That's really bad for everybody. For everybody involved, that's really bad. Okay?
We had a few of those, and it used to be really annoying. It used to be really annoying that we were still doing our best engineering practices, and these guys were shipping code. And it was awful code, but they were shipping, right? And so they won the credibility, not us.
Again, that's because we do not have proper standards in place to identify that somebody is doing a professional job, right? We don't have certifications of like doctors or lawyers do, right? We don't have a bar, right, that says you committed malpractice as a software developer. We don't have that. We should, right? I mean, the best we got is like internal code reviews and maybe managers that say, and here is kind of the system, the managers that are not willing to stand up to that project manager or whoever it is, right? If your manager is not willing to stand up to that person and say, I will not let my developers produce substandard crap for code just to reach your deadline. If your boss isn't doing that, you should be asking yourself why. Why not? Why is my manager not doing that? Why is my manager not interested in the professionalism that I put on in the code base? We have all these other standards. We have all these other things like, of my professional conduct, right? I can't be saying things in the workplace. There's certain constraints of what I can and can't do in the workplace. But by God, if I ship crap code, that's perfectly okay. And my boss is fine with that because it satisfied that project manager. That's not an argument that we should change our practices. That is an argument that we are not conveying to them, to ourselves or to the external world, of how professional we should conduct ourselves as developers, right? Okay.
Sometimes we used to come back to our tests when they were breaking, quite often because we were trying to change implementation details. We'd realize that we had no idea what the test was doing. Anyone had this experience? You go back and find the test is red, and you're looking at it and you're going, I have no idea what this test is for, and I have no idea whether the fact that it's red is good or bad at this point in time. Okay? This test seems to add two numbers and come to a result which I can't possibly understand how they could have originally ever got that result and why this test was originally passing. And now I've refactored it and it's red, surely just because the test is wrong.
Okay. So basically what he's saying at this stage is somebody wrote a test that we have to come back to. It's broken, but I don't know, or I shouldn't say broken. It's failing, right? The test is failing. I don't know what the test is for. And somehow that's an argument against testing in general or test-driven development? No, that is an argument that you need to be doing clean code practices. You should be naming your functions properly, including your tests, right? And you should be, the functions that you write should be properly named and small enough, right? You still need to adhere to the solid principles even in your tests. Single responsibility principle, okay? You should have functions, very small functions, that do very, very finite things, very small, little, tiny, detailed things at a time, so that you can understand what the functionality and the behavior is of the application. You should be doing that in your tests as well as your production code. So this is not a failing of test-driven development. This is a failing of the developer who wrote the test to properly label it. That's, or even, show what the logic is. Or the system is so complex that you would get confused by the addition of two numbers. That should be a red flag, not for the test, but for the person who is designing the system. They're not following good, proper, clean code practices or solid principles. Okay? And by the way, once again, don't change the test. Replace it. Write something new that replaces that one. Don't fix the test. Don't modify the code. Don't modify the test. You make a new one. That's the whole point. Okay.
But lots of tests just don't really give you any information, especially the ones that are like swarm with mocks. And you're kind of like, what is actually under test here? They don't have that experience. They've looked at the test and they finally realized nothing is actually being tested apart from the mocks. Right? Someone's written this thing and mocked it so heavily you go, there's no real code actually under test here.
Okay. So this is really the fault of the developer to refactor. Test-driven development is a cycle. You write a test that fails on purpose. You then write the implementation code that satisfies the test. The smallest, easiest, quickest, dirtiest way to make that thing pass. Then the third stage is refactor. And when you refactor, you are fixing things like what he's talking about. So really what he's saying is, quite often developers don't refactor their code. That's true. How is that an argument against TDD? How is that an argument against test-driven development? That just means the developer did not properly refactor the code, or they weren't testing the right thing, or they were doing testing in the wrong way. And mocking something up, okay, yeah, mocks are great. Mocks, I love mocks. I mock a bunch of stuff. Yeah, I'm one of those guys. I love mocks. They're great. Would I ever just write a test that just mocks? Writes the test against mocks? That just basically means you forgot the system under test. Why not just delete the test? If you write a test that doesn't even have a system under test involved in it, why not just delete that test? Just get rid of it. Okay, that's not an argument that test-driven development is wrong. That just means you guys have internally bad practices. All right, I'm going to leave it there because, obviously, I went from like 7 minutes, from a 7-minute mark to the 14-minute mark. I went through 7 minutes of this talk, and I found 10 things that were wrong. So I just couldn't bear with it anymore. One thing, if you are interested in learning about test-driven development and just kind of understanding the classic versus London or Chicago versus London style, there is a really great series that Uncle Bob puts out. You guys know me. I love Uncle Bob. I think he's a great guy. Some of his videos are just editing nightmares and I can't watch. But this series here on London versus Chicago is really excellent. And the thing is, it is for Java developers. It was written for Java. But if you know C#, you can follow along. Okay, Java and C# are like twinsies. They're very, very similar. If you watch this, trust me, you're going to completely understand what's going on, even if you don't write Java code. It's going to look pretty similar. So I really recommend that you go watch this series. Watch at least, I'd say, the first. So basically, it's a comparative study that they do. One guy, I forget his name. Sandro Mancuso. Sandro goes through and does the newer London style where you do outside-in test-driven development. You write your end-to-end tests first, and then you start to build the system underneath that. Whereas Uncle Bob does the more traditional TDD style approach of inside out, which is called the classic or Chicago style. And it's just kind of a good little contrast of the two different ways of doing test-driven development. So if you're interested at all in how TDD works and you kind of want to get some different perspectives on it, I highly encourage you watch this comparative case study that they did between the two different styles, because you'll learn so much out of this. I loved this series. It was one of the best series I've ever watched on anything to do with test-driven development or testing in general. So I highly encourage it. I'll put a link in the description when I post this up. So let me just check for any last chats. Let's see, survivalism. How do you make entity framework work? Where I was last, it was so slow they abandoned it and went back to stored procs. All right, so first of all, there's some things. So entity framework is going to be hitting your database for things all the time, right? The best thing for you to do if you're running into some slowdowns with entity framework is to take and just get your data collections of things. And by the way, views are good. I like views. Okay, so if you have a view, there's nothing wrong with a view, which is really just basically a stored, select query, right? That's really all a view is. But if you have views that kind of form the data in such a way that you need to read it, that's good. If you are looking to do a lot of writing back to the database and you're slowing things down, you can write to a database using just a regular old SQL query with entity framework. You can do that. And I've been in some situations where that was definitely the beneficial way to go about it is to, write my SQL query that's going to insert the data or to update the data more directly instead of using a SQL, entity framework. If you're doing a bunch of record changes and stuff, then you're really going to want to have to do that. And there are other strategies too of doing that, but I just found that it's easier to do that. If you're dealing with slow reads of your data, then you might want to consider putting that into a view and then just calling that view instead of the data. So typically what I would do is if I'm trying to deal with something that is slow with Entity Framework, I have to first analyze, is this slow because of the amount of data I'm getting from my query, or is this slow because I am inserting or changing a lot of data on the database? And sometimes the slowness of the database is actually because of the structure, that I have too many other calls being made to the database and it can't handle it all without doing some record locks. So in that case, you might actually want to split up your database into two and have one, you start doing clusters and stuff so that one is what you write to and the other one is what you read from. That can often help with the speed. But if you are running into speed issues and you think that it's Entity Framework that's doing it, just analyze. You can always do a SQL query, right? You can just do a straight up SQL query to it. If you're doing a stored procedure, you realize that your stored procedure is going to slow down the database. Okay, it's going to cause some sort of slowdown. 30 joins. If you're doing 30 plus joins, then again, you could put that in a view instead of doing a stored proc. And I know that some people prefer stored procs because there's some caching that goes on there. And it, certainly can behave a little faster through the stored procs. But honestly, the problem is that you're obfuscating the actual logic of the system when you're doing that. So if you have 30 joins, understand you can load up all the record sets into memory, all the data sets into memory on the application, and then do joins. So one thing you might want to do, Survivalizer, is whenever you pull the data from, say, doing the Entity Framework, you can just get the records from Entity Framework and put them, do a to list on it. If you do a to list, then that basically drops it into a new memory, an object in memory. And then you can take, those 30 different tables that are all now in memory, and then you can join on them. And that's going to be just about as fast as a stored procedure. But you do have to go collect that data. So that's probably the more time-consuming thing, is the collection of the data. So either you need to, kind of use views in your database in order to kind of narrow down the data set that you want to work with. And again, if you're just doing a 30 plus join query, you don't have to use the Entity Framework object relational mapping process to do it. You can just write the SQL query on your database context and just do that and execute it, and then convert the objects, to convert the data set back to an object. You can just do that if you run into those issues. So, but I still think that avoid stored procedures as much as possible. That just really, they obscure the business rules and the logic. Yes, they can make things go faster in some cases, but you can fix that by kind of doing it on the code side. You just have to implement those strategies. Like I said, just do a straight SQL query to collect the data you need. Okay. All right. I don't see any more questions. Thank you so much, everybody, for joining me today. I really appreciate everybody who jumped in on this. Feel free to drop me any comments in the comment section below this video. Again, I will leave you the link to the Clean Coders. They call it comparative design. This is London versus Chicago. They are writing in Java using IntelliJ, but don't let that frighten you. If you know C#, this is still going to make plenty of sense to you. It's not gonna, just because it's in Java, the languages are so incredibly similar, you're not gonna be confused at all. Okay, so thank you so much again to everybody for joining me, and I hope to see you guys in the next stream. Bye-bye.